At this point, we have already investigated how to transition between a few of the different forms of a quadratic relation. So we know how to expand factored form to standard form. We know how to expand vertex form to standard form. And from factoring, we now know how to go from standard form to factored form, depending on what the equation is, right? If we can use the multi-step factoring from the previous video. So now we are going to look at how we can go from factored form to vertex form. Okay, so a reminder here, this is what what factored form looks like, is y equals a multiplied by x minus r multiplied by x minus s. So the information that we can determine from factored form is the following. So from the a value, I can determine the direction of opening. Okay, so if it is a positive A value, it's opening up. If it's a negative A value, it's opening down. When it's opening down, we can also refer to that as a reflection over the x-axis or a reflection in the x-axis. The A value also tells me the vertical stretch factor, and it's by a factor of the absolute value of A. Okay, so the positive value of A. So if your A value is like -6, there's a vertical stretch by a factor of 6. Okay, we don't need to say by -6. And just a reminder that in this course, we're not going to use the compression language, okay, vertical compression. We will just call everything a vertical stretch if there's an A value that's not 1. Depending on if you've taken this course before or on your teacher in grade 11, typically they'll start to use the stretch and compression language then, but just kind of for the sake of understanding what's happening, we're just going to call everything a vertical stretch by a factor of whatever the A value is. Okay, so that's one thing, or I guess two things we can determine from the factored form, and the other thing we can determine from the R and S values is the x-intercepts. Okay, and they are given by R0 and S0. Okay, the y coordinate of them is always 0 because they're on the x-axis. And the important thing to note here is that you are flipping the signs. Okay, so I've mentioned it before, I say it a lot, but your x lies, you are going to flip the sign. Okay, so you make sure that if it's like, for example, if you have x plus 3, then your intercept there would be -3, 0. Okay, just because of the way that the formula is written, we write it as x minus r. So if r in this case is -3, x minus -3 is the same as x plus 3. Okay, so if we have factored form, we can tell the x-intercepts, and we can use that information to help us determine the vertex of the parabola. So I'm going to write some steps, but I first just kind of want to show you where this comes from. So if I were to draw a parabola, we know that it has to be symmetrical directly through the middle, through the vertex of it. Okay, and we know that we have what's called the axis of symmetry that cuts through the curve, and it cuts it directly in half. Okay, so we've already investigated how we can determine that if we know the vertex, and also just um, from a graph. Okay, so let's say this is my axis here, my x-axis, and let's say this is my y-axis, my x-axis. So if this is an example of a quadratic relation, I can see here it's being cut directly in half. Okay, so I would have some value of my vertex, and my x-intercepts would be, there'd be one right here and one right here. It's not quite exact on my diagram, but it looks like it's right at the origin. And we know that because the axis of symmetry is directly in the middle, what we know to be true is that this distance here and this distance here would be the same, right? Like if we were to draw like even like a line like this to show that they are equal, right? So if I was measuring from my axis of symmetry to the x coordinate of the x-intercept, it would be the same distance, okay? So like let's say this, well, this point here we can see is 0, 0. So if this point was like, let's say 5, 8, from 0 on the like at the origin there to 5, that is moving 5 units over. So then this would be at 10, 0. Okay, so then that would mean like this from 0 to 5 is where this is. X equals 5 is my axis of symmetry, is 5 units, and then from 5 to 10 is 5 units as well, so it's symmetrical. Okay, so that's kind of the idea that we're keeping in mind when we are using this method. So that's, again, just kind of like an arbitrary example, so you can see where this is coming from. So to find the vertex of a parabola from factored form, the first thing you are going to do is determine the x-intercepts, okay, which again I said are R0 and S0. And again, the most important thing is remembering to flip the sign, because that is such a common mistake. I make that mistake sometimes too. If you don't flip the signs, then your calculation in the next step is going to be incorrect. Then once you find those x-intercepts, you can determine the axis of symmetry. I'm not going to write the whole word because it's too long. So because I know that the distance here has to be equal, I can say that the axis of symmetry is the middle point, or at the average, the halfway point between the distance between my x-intercepts. Okay, so the way that I kind of express that as an equation, you'll see me write this. I'm never going to write axis of symmetry in words because, like I said, it's too long, and I don't know, math is not for for writing long words. AOS is axis of symmetry. So the equation for this, we know the equation for the axis of symmetry is always x equals something. So the way we calculate it is we're going to do R plus S divided by 2. Okay, so whatever the value of my x-intercept was here and here, that's after I've flipped the sign from the equation. Okay, you don't flip it again from this. So like I said here, if we had x plus 3 and we determined that one of the x-intercepts is -3, then you're putting -3 into here. Okay, so you're adding the x-intercepts together, dividing them by 2, and that gives you an x equals equation, which represents a vertical line, which is what the axis of symmetry is. Then once you have that value, you are going to sub it back into your equation. Okay, so sub x equals number, okay, whatever that might be, from step 2 into the original equation. And that will give you the y value of the vertex, which is like the max or min value of the curve. Okay, so let's look at it with some actual numbers, because again, math is usually more understandable when you can see it with numbers. So this example here, I'm not asking for just the vertex. I'm asking for you to tell me everything you know about the following quadratic. Okay, so we are given this equation in factored form. I have y equals -3 multiplied by x minus 3 multiplied by x plus 1. So before even doing anything to manipulate the equation, I can determine a few things. So I know that it is going to open down. Okay, I know that because I have a negative a value, that -3. I know that there is a vertical stretch factor by a factor of 3. Okay, and I know that because it's the absolute value of my a value. So just 3 is fine. You don't need to say -3. And I know that my x-intercepts are +3, 0, and -1, 0. Okay, so again, when we're looking at this here, your x lies, so this gets flipped and this gets flipped. Okay, so that's where the +3 and the -1 are coming from, so make sure that you do that. So those are the three things that I can tell from the equation without modifying it at all. And we just learned how to find the vertex, so that's what I'm going to do over here. Okay, so I'm going to say find vertex. So I said that I'm using my equation for the axis of symmetry. My equation is x equals r plus s over 2. Okay, and again, r and s are the x values of my x-intercepts. So I said they were 3 and -1, so I'm going to do x equals 3 plus -1. Typically, I'll just show this as 3 minus 1, okay, but just to kind of show you, it's always adding them, but obviously if one's negative, then it's going to be subtracting, divided by 2, which gives me, so 3 plus -1 is just 3 minus 1, so this is 2 over 2. So my axis of symmetry is x equals 1. Okay, so the curve is symmetrical on either side of x equals 1. Then I am going to sub x equals 1 into my equation. So the original equation I had here, so y equals -3. And then I had x minus 3, so I'm going to do 1 minus 3 multiplied by 1 plus 1. A lot of times I see students look at this and they can sub the value in and then they think, how do I calculate this? It's just bad math. Okay, so simplify in both the brackets first and then you're just multiplying. So you'll have -3 bracket, 1 subtract 3 is -2. 1 plus 1 is +2. Okay, so you're just simplifying within each bracket first. That's this and this. And now you're just multiplying, right? This is just -3 times -2 times 2. Okay, so -3 times -2 is +6 times 2 is +12. Oops. Okay, so then that means that my vertex is 1, 12. Okay, so it's that easy to find the vertex from your factored form. So then with my list over here, I can add that. So I can say my vertex is 1, 12. And we know from the vertex, from that information, and also with what we calculated, we can say my axis of symmetry is x equals 1. And my max or min value for this, I'm looking, my equation opens down, I said for my first item. So that means the curve looks like this. So if you're ever not sure if it's a max or a min, I think most of you can confidently tell me if it opens up or down based on if it's a positive or a negative number at the front. So if it opens down, just draw yourself a little sketch like that, and that means your vertex is going to be here, which is a max, okay? So you have a maximum value of y equals 12. Okay, if it was opening up, then it would be a minimum value. And the only thing that we're missing here now is the y-intercept. So there's two ways we could find that. We do know how to expand from factored form. So I'm going to show that just so we can practice that skill. Okay, so if I wanted to expand, I'm running out of room here, but that's okay. I'm going to do y equals -3, x plus 3, no, sorry, it was x minus 3, x plus 1. Again, when I'm expanding, I'm multiplying everything in the first bracket by everything in the second bracket. And you can show those arcs there if it helps you. Okay, so I'll have y equals -3 bracket, okay, because I need to multiply the -3 after. X times x is x squared. X times 1 is just x. -3 times x is -3x. And -3 times 1 is -3. Okay, so you end up with 4 terms. You can collect the middle two. So y equals -3 x squared minus 2x minus 3. And then to fully expand that, I'm multiplying -3 by everything in the bracket. Common mistake that I see here is only multiplying it by the front term. Don't do that. It gets multiplied by everything. So -3x squared plus 6x plus 9. Okay, my c value is 9, which means that the y-intercept is 0, 9. Okay, so I could put that here. My y-intercept is 0, 9. And I now know pretty much everything that I can know about the equation. Okay, I know the direction of opening, the vertical stretch factor, x-intercepts, vertex, axis of symmetry, maximum, and y-intercept. One option that you can use as well, you'll come to find out quickly that, especially in the next, the second unit of quadratics, there will be many methods that you can use to solve things, and it's kind of just a matter of personal preference. Another way to find the y-intercept is we know that x must be equal to 0 for the y-intercept because it's on the y-axis. So you can just let x equal 0 in your equation and then solve. So for this example, we would have -3 times 0 minus 3, 0 plus 1. And then we're just calculating. Okay, so if I simplify within the brackets here, then this is -3, this is +1. And then we just have -3 times -3 times 1. Y equals 9, and that's my x-intercept. Okay, so it's up to you. That way is obviously faster. I mean, I showed like a lot of steps when I was expanding. You can skip a few if you are confident in your algebra and expanding skills, but this way is faster as well. Okay, so then if I wanted to draw a quick graph of this equation, of this curve, to see what it looks like, I now have enough information to be able to easily do that. Okay, so if I make my graph here, or my grid, we don't have any negative values, right? Okay, so I'm going to put x-axis here, y-axis here, whoa. And I'm going to go up, this is 2, 4, 6, 8, 10, 12, perfect, that's exactly how high I need to go. And same thing here, 4, 6, 8, 10. So I don't need to show like every one of these things on here, but I'm gonna kind of just show you so you can see where everything belongs. So the first thing I said is that it's opening down. Okay, there's a vertical stretch by a factor of 3. That's not really gonna help me to plot anything yet. I'm going to plot the points that I know first. So I know my x-intercepts are 3, 0 and -1, 0. Okay, so 3, 0 is right here. -1, 0 is right here. Okay, so I can plot those points. I also know I've got my vertex at 1, 12, so that would be here. And then I said that my y-intercept is 9, so that is here. Okay, so that's kind of, it's nice to have those few points. And then something you might recall from when we were using the table of values to do transformations is that because this is symmetrical about the axis of symmetry, which actually I'm going to put this on here first. We said the axis of symmetry was at x equals 1, which is right here. I guess, sorry, that's kind of hard to see since it's blue like my lines are. Okay, so if that's my axis of symmetry, I know that everything on this side of the parabola is going to mirror everything on this side. So because I put my y-intercept here already at 9, I can see if I'm starting at my vertex, I'm going over and then just over 1 on the x-axis to get to where that point is. So if I go over 1 to the right, then I can put a point here as well, and that's the point that is symmetrical in terms of where it's going to go. Something that I don't think I've shown you yet, but is how you can tell from the graph what the vertical stretch factor is you can look and see what the step pattern is. Okay, so from your vertex, you're always going to go 1 over, It will always be exactly 1 unit. So if your grid is each square is 1, then that's fine. If it's not, just make sure you pay attention to that. So I'm going 1 over, and then I'm seeing how many, like what my changes in the vertical axis to get to the next point. So in this case, it's 3. Okay, so I'm always going over 1, 3, and my first step there, that tells me what the vertical stretch factor is. Okay, so vertical stretch factor is 3, which I already knew. Okay, I wrote that from my equation, but you can use that to help you create the graph as well, just to at least get your first step going. And the other pieces of information I have don't really help me to do anything at all. So now I just need to connect my points. Okay, so I'm just going to draw a smooth curve connecting, whoa, okay, all of these points. Not an actual very smooth curve. Oh, and one sec, let me retry that. My iPad did not want to help correct this here. Okay, and it's not going to do it there either. Okay, close enough. That's fine. This probably looks more similar to how your graphs look without the assistance of technology perfecting your lines. Okay, so that's fine. Your line does not need to be perfect. I'm not expecting you to be a robot. That is a good enough curve, and that would be a sketch or a graph, whatever you want to call it, of what that parabola would look like. Good communication says that we would label this. Usually I do it like where the arrow is that I'm showing extends on. So y equals -3, x minus 3, x plus 1. That is my graph. Okay, and that's a realistic representation of it, and I graphed that from everything I could tell from the equation. I didn't need to make a table of values. I didn't need to do the transformations from vertex form. I was able to easily convert between forms using expanding and using what I know about the x-intercepts and the axis of symmetry.